Hello. So this is the video for the final project for Group Four, right? So this is our VHDL implementation of the 8-bit divider, right? So this is our ASM chart, which has five states, right? Which is A is the reset stage, right? The initial stage, and then B is the initialization stage, and then E is the condition, right? The divide by zero condition, which then leads to C, right? Which is the comparison, and then state D is the subtractor and the counter state, right? And these two stages will kind of loop until R is less than B, right? And when the remainder is less than the remaining values, then we output the values and go back to the state A. Yeah. So and this is the schematic diagram. As you can see, we use one, two, three, four entities, right? which which is the subtractor, register, and comparator. And we also have a 8-bit counter here to keep track of the quotients. Okay, so this is our state diagram, which is kind of similar to the ASM chart, right? Where we have the five states and how each state moves from one to another, right? Yeah. And this state says what happens at each state, right? So what register channels get triggered when you move from one state to another, right? So for example, state E here, you you load load the data in, right? To You load the data in after state B, and then you check for the zero condition. Yeah. So now let's go into the VHDL code, and which is pretty simple. Right? We have our initialization, right? So our ports, our ports, our clocks, our processes. Also, sorry, is this one? Yeah. Our ports, our clocks, right? And now we define our entities, right? Our chips, which is the subtractor, which is basically just a minus B, right? Into the difference here, right? The comparator is also kind of simple, right? So we have a yeah. So we just compare the R, which is the remainder, and the B, which is the like remaining value, right? And E and Z start the comparison, and then we have some exit conditions or like exception handling here. Yeah. Right. So if it's one, then and it's not zero, right? Then we will just return the either this condition, which is like R is greater than B. Yeah. So and this is the counter, which is just an increment, right? It's just an in increment here. And yeah. So this is now the important part, which is the controller of the state, right? So we start by initializing the clocks and the initial state, right? And now we define each state, right? So for example, A, as you can see here, we A will go to B if start is one, right? And it will return to A if start is zero, right? So and that happens for all these states, right? So just defines what happens at each state, right? So here you said busy, right? So for example for B, right, you said these conditions. Yeah, and here we just connect the each entity together uh, according to this RTL, right? Yeah, so we just connect everything together. And now let's look at the test bench, right? Which just runs these 5 tests, right? So we check for a normal division, a, a a division where the divisor is greater than the dividend, a an exact division where there's no remainder, a divide by zero condition, and a zero divided by something. Yep. So here is our simulation, right? So as you can see, it's working as intended, right? So here it's 10 divided by 3, if I remember correctly. Yeah, 10 divided by 3, which should get 3 remainder 1, right? So here is 3 and here is 1, right? So Q is equal to 3 and R is equal to 1, and it's all the same. And for our but for our divide by zero condition, right? We just check to see that the state goes from A to B to E to A immediately, right? So there's no computation going on because the the device will check if it's a zero. Yeah, so that's about it. Thank you.